Hey everyone, welcome to the Things Industries webinar on supercharging LoRaWAN with AWS and the Things Stack. My name is Johan Stocking. I am CTO and co-founder of the Things Industries, and I'm joined today by Karthik and Chris. Karthik, please introduce yourself shortly.
Hello, everyone. My name is Karthik Ranjan. I'm part of the AWS IoT partner team, and I'm responsible for LoRaWAN ecosystem development. Chris, over to you.
My name is Chris Wood. I'm a partner solution architect working across UK and Ireland, and I'm also part of the IoT specialist team. Over to you, Karthik.
Thank you very much. Let's go to the next slide, please. So we've prepared an agenda for you today. We're really excited to share with you some of the new integrations that we've done between TTI and AWS IoT. We'll begin by covering the business opportunity for LoRaWAN and IoT. Then we'll share with you some of the work that we've done with the Things Industries. We'll cover the Things Stack architecture and how you can deploy the solution. We'll cover the integration with AWS IoT. And then we'll also share with you some of the sample applications that you can build on top, followed by a short QA. So let's jump right in. According to McKinsey & Company, the source of data is going to come from billions of devices, 75 billion to be precise. These devices can be as complex as a connected car generating terabytes of data every day, to a camera that's streaming video and generating gigabytes of data, to industrial controllers that may generate megabytes of data, all the way down to a small battery-operated temperature sensor streaming just bytes of data a few times a day, yielding a battery life for up to 10 years. So this begs the question, what is the best mode of connectivity for me to use? And what are the factors that will determine the best way for me to connect? Typically, there's several considerations for IoT network designers to think about, not just one parameter. These are things like distance, bandwidth, power, CapEx, meaning what is my upfront hardware and software cost, and finally, OpEx, what are my ongoing costs? Here in this slide, we look at just two metrics, distance and bandwidth. We can look at Wi-Fi and notice that it's a high bandwidth short range technology. In the previous example, we talked about the connected camera. In that example, given the high bandwidth nature of the camera, Wi-Fi probably means it also consumes quite a bit of power, hence why it might need to be plugged into the wall. We also see that 5G and LTE offer long range as well as high bandwidth, meaning it does use lots of power, but it's great for use cases like a connected car where you have to roam and send lots of data. Zigbee and Bluetooth are also lower bandwidth, but they operate in 2.4 gigahertz range, giving them a short distance. Which brings us to the bottom right quadrant, which is small data over long distances, otherwise known as LPWAN. This is the basis for long-range wide area networks. Let's take a look now specifically at LoRaWAN. So LoRaWAN is about sending small data. This is bytes of data. This could be a temperature or a door open close. And this is sent over long distances. LoRaWAN is gauged to be able to provide coverage over 10 kilometers in distance. And it also does this at a very low power footprint. We're looking at milliwatts of consumption and in some cases yielding more than 10 years of battery life depending upon how much it transmits. It's also a global solution with the band being standardized in various countries around the world. The other important factor of LoRaWAN is that it's bidirectional. Some LPWAN systems are only one way. LoRaWAN does offer full bidirectional capabilities, allowing you to both send and receive data to devices. The other benefit is public and private network deployment options, meaning if you don't want to deploy a gateway, in Europe, for example, there are many operators that offer public networks. The Things network is also a public network where customers can buy a sensor and connect it to the cloud without deploying gateways. We also have private deployment options as well, where if there is no coverage in your area for a public network, you can deploy a gateway, deploy your sensors, and connect that data to the cloud. LoRaWAN also offers firmware updates over the air, allowing you to update the image of your firmware of your sensor remotely from the cloud. It also offers benefits such as geolocation, done very cost effectively and with a low power footprint. It also offers customers the confidence of end-to-end security, as well as features like deep indoor penetration for solving for use cases such as smart building. Now that we've reviewed the benefits of LoRaWAN, let's explore the ecosystem. LoRaWAN has become the default choice for LPWAN deployments with over 100 million sensors deployed. The success of LoRaWAN in large part is due to its broad ecosystem, including hardware, software, cloud providers, as well as large network operators. The standard is managed by a global entity called the LoRa Alliance, and supports both private and public networks catering to a wide variety of IoT applications, with both TTI and AWS participating as active members within the LoRa Alliance. Now that we've talked about LoRaWAN and the Alliance, let's now take a look at an application. Here we have a simple application where you have a LoRaWAN motion sensor that when a person walks by, it then turns on a light. Let's now take a look at this across a number of data points. Next slide. Here we've deployed this in a building, and we're now starting to see that from the morning, as more people enter the building, the light turns on consistently. Perhaps the traffic slows down a little bit mid-morning, but by lunchtime, we see the traffic going up. By evening, when people leave the office, we again see traffic going back up. In this model, the light can be turned on and off, or we can apply machine learning technologies to be able to predict when the right time is to keep the light on and when the time is to allow the sensor to activate. This brings us to our next point, which is really the life cycle of artificial intelligence and AWS IoT. Next slide, please. So if we look at the IoT customer journey, most customers want to get to the point of actually being able to automate and predict IoT. We need to move very quickly to get to the deployment and the collection of data from our IoT devices. Although most customers struggle with the generate and collect, in this webinar, we will discuss how AWS and TTI will make the process to generate and collect data simple using the TTI LoRa Network Server and AWS IoT. Let's now take a look at the portfolio of the offering from AWS IoT to quickly move to predicting. AWS IoT offers a portfolio of edge to cloud services to enable customers to quickly get to business outcomes. Starting with device software on the right, AWS offers free RTOS, an MCU-based operating system. We also offer Greengrass, which runs on application processor devices that allows you to orchestrate your applications from the cloud to the edge. We also offer SDKs to connect directly to the cloud, as well as the device tester to enable you to qualify your hardware and publish that in AWS's device catalog. Moving to the left, we have IoT Core, which is our device ingest service, which supports MQTT, WebSocket, and HTTP. Our device management services enables customers to track, monitor, and manage connected device fleets. You need to ensure that your IoT devices work properly and securely after they've been deployed. IoT Device Defender is a fully managed service that helps you secure your fleet of IoT devices. AWS IoT Device Defender continuously audits your IoT configurations to make sure they aren't deviating from security best practices. And finally, moving to the top, we have AWS IoT Things Graph, which is a service that makes it easy to visually connect different devices and web services to build IoT application. AWS IoT Events is a fully managed service that makes it easy to detect and respond to events from IoT sensors and applications. Sitewise is a managed service that makes it easy to collect, store, organize, and monitor data from industrial equipment at scale to help you make better data-driven decisions. And finally, AWS IoT Analytics is a fully managed service that makes it easy to run, operationalize sophisticated analytics on massive volumes of IoT data without having to worry about the cost and complexity typically required to build an IoT analytics platform. With that, I will turn it over to Johan to talk to you more about Things Industries products on AWS.
Thanks, Kartik. That was it's really interesting, and this aligns really well with what we do in LoRaWAN. So I'm gonna go ahead and introduce the product offering that we have, and also the integration between our platform, our product, the Things stack, in AWS. So what is the value that we offer together? So the Things Industries decided not to build an IoT platform because we believe that IoT platforms are really good or tied for specific cloud solutions. So public clouds offer an IoT platform such as AWS, but we also know that there are customers who want very low-level access or different ways to manage devices. So we focus really on the LoRaWAN network layer, and we rather integrate with IoT platforms such as AWS IoT. And we are very happy that we have a really advanced, if not the most advanced integration for LoRaWAN with Amazon Web Services. And the benefit for customers is that it's really easy to get started, and also that AWS IoT can be the primary interface for managing a LoRaWAN network, for onboarding devices, for working with device data. So we build a native connector, and I will also show that in a few slides on how that works and how you can deploy that. So everything is API first, so you can use the APIs of the Things stack directly. But since we have this native integration, you can also use the IoT Core APIs that are provided by AWS to create things, to get a shadow state from things that is all filled in automatically by the native connector that we built. Since the Things stack is a standards compliant LoRaWAN solution, you can connect any gateway, any LoRa gateway, and any LoRaWAN end device to a larger solution. Another reason why we have this integration with AWS IoT, and that's also presented before by Kartik, is that LoRaWAN is typically not the only connectivity solution in a bigger solution for a customer. It's very valuable to have a mix of LoRaWAN devices with cellular IoT connected devices and Wi-Fi devices, and a platform like AWS IoT provides just that. And the Things stack is designed to fill in that LoRaWAN part. So how does it work from a customer's perspective? So we have a listing on AWS Marketplace where you can deploy the Things stack in your own AWS account, or you can subscribe to our SaaS offering. Then there is a CloudFormation template that allows you to deploy the integration in your AWS account. And this integration connects your IoT Core environment that is in your AWS account to the Things stack that is either also running in your AWS account on compute resources, or that's hosted by us on our SaaS offering. Then you deploy a gateway, you deploy a sensor, and you're done. But first, what is the Things stack? So the Things stack is really best-in-class LoRaWAN network server. It's designed for scale. It's secure. We have APIs for everything. We do have a web interface, but the web interface is just a user interface around our API, really. So we have an API for everything, and we support different deployment models. And this is also to meet with many enterprise requirements where customers want us to be able to deploy on their infrastructure It could be their on-premises servers. It could also be AWS EC2 instances that they control and that they know in which AWS region that runs. Our proprietary the Things stack, our enterprise distribution, is powered by our open source project, the Things stack, which you can find on GitHub. And what we add in our enterprise distribution is more scalability, clustering, monitoring, and a few enterprise features such as a single sign-on with OpenID Connect, things like that. So really enterprise-grade features around our open source offering. And we have 3 commercial distributions that are available specifically for Amazon Web Services. So our stack, and I'm not going to go through all of this list, but it's feature complete. It supports all the LoRaWAN versions, the regions, the different ways of communication. We support interoperability with other networks and other joint servers. We also support more advanced LoRaWAN functionalities such as multicast. And in our design, we follow the LoRaWAN network reference model. So if you learn about LoRaWAN and you learn about joint servers, network servers, application servers, those components are really what we have in our stack. So we don't have our own interpretation of LoRaWAN, we just follow the reference. And we also provide a lot of insight in what's going on. So you can subscribe to all sorts of events. And you can view exactly when gateways connect, when they disconnect, the metadata of each message. And you can also see exactly how end devices are how they are behaving on the network. So the 3 deployment models that we have in AWS first is what we started with a bit more than a year ago with our AMI listing, an Amazon machine image on AWS Marketplace. And this is a really simple way to launch the Things Stack Enterprise in your AWS account by using our machine image, and you pay for the number of devices that you have on your network. The second is our scalable, our larger deployment, which is using ECS, Elastic Container Services, and that allows you to deploy the Things Stack as a number of containers in your AWS account. And this supports horizontal scaling, so you can run all the components in a replicated manner, and this supports really large-scale network deployments. This is a bring your own license approach. So you don't have to subscribe to AWS Marketplace, but you can really deploy this in any way you like, and you can just get a license key from us and configure the stack. Our third option, and that's what we're really excited about, is our SaaS subscription. So this is offered through AWS Marketplace. And instead of deploying the Things Stack on an EC2 instance in your AWS account, or operating the ECS deployment that also runs in your own AWS account, the SaaS subscription is subscribing to a fully hosted and managed solution by the Things Industries. So you don't deploy any resources in your own AWS account, but you subscribe to an offering provided by us. And we also support a service level agreement, and we have multiple support plans around this. And this is also where the integration is really valuable, because you can connect your AWS account with our hosted managed environment. So you have device management and device telemetry in your own AWS account, while the network is managed and operated by us. And that's all in a very a secure way, supporting even LoRaWAN end-to-end security, as I'll show in a bit. So we have different deployment models, and we are aware that it can be quite overwhelming. So here's an overview of, on the left, you see the different deployment models, and in the columns, you see the features So I won't go over all the boxes right now, but you'll see that the SaaS listing, so the second row, is actually the most feature-rich deployment, and that's also operated by us. So you don't have to manage any resources yourself. But again, if you need to control for compliancy and governance reasons on which AWS resources your network runs, you can deploy an ECS or use the AMI image. So our pricing model follows value. So we believe that value is in the data generated by devices. That data is yours. It's your devices. So we don't charge per gateway or on time units or anything, but we rather have bundles of connected devices per month. And just as an example, if you start with 1,000 devices on our AMI listing, you pay for the network server €190 per month. And just for the AWS resources for the EC2 instance, it would be around another 60. You can go to our website and use the calculator, as you see here on the right, to see exactly what the license fee is for the number of devices that you deploy. So the costs to start are pretty low. So then the AWS IoT Core integration. So what did we build? This integration is not only supporting uplink and downlink messages. That's obviously one of the features. But what is unique to this integration is also that we support LoRaWAN end-to-end encryption. And that means that device data gets encrypted on the end device with the LoRaWAN application session key. Then it gets transported to the network layer, and it gets delivered still encrypted to your AWS account. And that is where the application session key resides. That means that we can do all the routing and device management without having to know the actual payload that your device is sending. Another key feature is that we chose for a serverless design, and that means that if you deploy the integration, there are no compute resources deployed in your AWS account. So that means that you don't start paying immediately for compute resources. This is because we implemented everything in Lambdas. So only if there's traffic, if there are device activations, then those lambdas get invoked, and you start paying only for the execution time. The CloudFormation template can be used for the AMI listing, but also for SaaS and for the ECS deployment. So next to messaging end-to-end encrypted, you can also manage devices directly in AWS IoT. And the LoRaWAN metrics that the network reports are updated in the thing shadow state. So you can find in each thing shadow as metadata of the end devices, which can be very useful to see the population health of your end devices. And finally, next to creating things manually, we also operate a global join server. We work with dozens of device makers to pre-provision their devices in the join server, and you can claim these devices directly via your AWS account, so that you don't have to manually transfer any security keys. So this is the architecture. So these are all the resources that are deployed when you deploy the AWS integration. What's important to note here is the customer is on the left. They subscribe to, in this case, the SaaS offering, and then they deploy the CloudFormation template. And what is deployed in the customer account are a couple of Lambda functions that are acting upon things that happen in IoT Core. So when, for example, the customer creates a thing, there is an IoT Core rule to trigger a Lambda, and the Lambda then creates the device in the underlying network, for example. With a cross-account role, the thing stack can publish device data directly to IoT Core. That triggers a Lambda, and then the Lambda can decrypt the payloads and republish it. So this is sort of the idea of the integration and how it works. You can find more information about this also in the linked resources that we have next to this video. But yeah, pictures and videos say more than 1,000 words. So let's go to the demo to show you how this works. So this is our documentation where you can go to learn about the integration. And there's also a button here to deploy the integration directly in your AWS account. So go ahead and select your region and click the button to deploy for cloud hosted. That brings you to the CloudFormation setup where you can enter the name of your stack. And then we have a bunch of parameters that are specific for this integration. So you can configure the integration here, and then you enter the cluster where you want to connect your application. So this is the application, this is the thing stack. And I have a couple of devices here that are sending data all the time. And you can copy the cluster address that's in your address bar to the CloudFormation template. There are other ways to get this, but this is quite easy. You can enable or disable end-to-end encryption. Just for the demonstration, I'll disable it for now. And then you need to configure the application that you want to configure the integration for. So you copy paste the application ID, and then you go to API keys to create an API key that is specifically for the AWS integration. The reason is that the API key is used to create things, to update things, to subscribe to traffic. And so with the API key, you basically authorize the integration to connect directly to your application of the thing stack. So I now copied the API key, and I can paste it right here. That's it. Just acknowledge that there are some resources created. Again, there's no compute. It's only serverless functions. And then the stack gets created. This takes a few minutes, so you can refresh this and see the progress. And after about 5 to 10 minutes, the deployment is done. And then the resources are created. So what happened also in the meantime is that the integration is configured in the thing stack. So you can go to the PubSub integrations, and here you see the AWS IoT integration that got configured. And here you see the CloudFormation stack name that we entered before, and also the cross-account role that the thing stack uses to send data to your AWS account. So I have a bunch of end devices here that are continuously sending data. And now I want to go to AWS IoT to see this data. So this was before I deployed the integration, and I don't have any things. But when I refresh this page, you'll see that the things are created automatically because the integration sends the data to your AWS account. The Lambda function automatically creates these things. So you can open a thing and you can find some of the attributes here. But more interestingly, you can also go to the shadow state, and you can find here the shadow state of LoRaWAN. And in that document, you can see some metrics that can be useful to see the health of the end device. How many gateways the device is covering, frame counters, the device address, and some metrics on the radio level. So that's quite useful. So that's the thing registry. So let's go to the data. So you can subscribe just like any other IoT solution. You can subscribe to a topic. You can find the topic structure in the documentation. And if you subscribe, you see here the data that the devices are sending. So it's an uplink message from this device with all the identifiers. There's a lot of metadata here from LoRaWAN, so the port, the counter, the actual payloads, and then a lot of metadata on the gateway from the gateways that received the message. There was some packet broker routing, and you can see the frequencies here and everything, and even how much airtime the message consumed. So a lot of metadata next to just the actual payloads that your device is sending. So this is a quick demo of how you can deploy the integration, and that the things are being synchronized automatically. You can also use AWS IoT to create new things, to claim things, to delete things even, and you can subscribe directly to the MQTT broker and act on data, just like any other IoT Core solution. So I'm now going to go ahead and we'll move to Chris, and Chris is going to talk about some sensors and also a live demo of what you can do once you have deployed the integration. So Chris, please take it from here.
Thanks very much, Johan. To complement the TTI AWS integration, we've developed a few sample apps to help customers get value really quickly when connecting LoRaWAN devices through a TTI network server. These are available for download along with full deployment instructions from our GitHub repository, and we're going to give you the details of that URL. Within this sample demonstration here, we're targeting 2 devices. The first of which is this Tekelek smart tank sensor. So this is an ultrasonic LoRaWAN sensor. It's battery operated, and it has an integrated LoRaWAN radio. All you have to do to fit it is drill a hole into a liquid or a gas tank, screw in the sensor, and then it will start, you configure it, and then it will start reporting the ullage, which is the space above the liquid surface periodically. And you can configure it to raise alarm messages if the level drops below a particular level. So in order to simplify the processing of data from this device, we've provided a really simple sample application. And this is a typical application for processing LoRaWAN data from the TTI LNS. So you can see top left is the sensor. The sensor's connecting through a gateway to the LoRaWAN LNS. That would have previously been set up as a device and given an app key so it can encrypt the data across the LoRaWAN network. The LNS will decrypt that data, and then using the IoT connector that Johan demonstrated, pass any packets, messages coming from the sensor up to IoT Core here. You can see they'll be passed over as MQTT. In the case of the Tekelek sensor, the payload's actually hex encoded, which is why we wanted to simplify this. So after receiving the messages from IoT Core, you saw the messages appear in Johan's demo on a topic, and a rule set up as part of that CloudFormation template will handle that Lambda uplink. And in addition to updating the device and device registry and creating a shadow, it passes the messages onto a device-specific topic. So from there, part of the sample, what we've done is created a transform lambda that decodes transforms the hexadecimal into a JSON object and passes that down onto an enhanced topic. There's a rule running off that enhanced topic that then passes that data into DynamoDB, so you can do downstream processing, as well as passing the data on to IoT analytics, so you can very quickly retrospectively look at that data within a QuickSight dashboard or other visualization tool. The second device that we're going to be talking about today is the Bosch XDK. So this is a cross-domain development kit, and Bosch described this as a programmable Swiss Army knife for IoT solutions. And basically, it's a rapid prototyping tool, but can also be used as a programmable sensor node within production deployments as well. It's really interesting, and we're using this in a demonstration because it has 6 sensors built in, and you can buy an optional LoRaWAN module. So very quickly, out of the box, you can get up and running and start visualizing data streaming from the XDK. You program the XDK using a piece of software from Bosch called the XDK Workbench, which is a variant of the Eclipse software development environment. And that comes pre-configured with a number of sample applications. And within this sample application, we're using a LoRaWAN sample that takes advantage of the LoRaWAN module. The inbuilt sensors that it features are an accelerometer, gyroscope, magnetometer. The 4 sensors that we're actually going to be using in the sample app are humidity, pressure, temperature, and a digital light sensor, and it also has an acoustic sensor as well. Next slide, please. Okay, so this is the sample application architecture for the Bosch XDK. Again, you see the device on the top left-hand side communicating through the LoRaWAN gateway. This time, because TTI provide a KN LPP payload formatter, and that happens to be the format that the XDK LoRaWAN sample application uploads in, we don't need a payload decoder in this case. So we can actually build a Lambda function coming straight off the uplink topic, and that can be used to process the downstream data. In this case, what we're actually doing is using AppSync with a real-time front-end application, so that when we receive uplink messages, we will create a GraphQL mutation, which is basically an update, a real-time subscription endpoint within AWS AppSync to allow a downstream React.js app to receive that data that it's subscribed to instantaneously. In addition to that, we also stream the data through IoT analytics, and I'm going to give you a very quick demonstration of visualizing that using QuickSight as well. The demo application authenticates using Amazon Cognito, using federated login, and also has a number of features around mapping the devices using the GPS coordinates that can be provided. Those aren't provided by the XDK, but other devices, if they do provide GPS, can be mapped with the sample application as well. So if we can share my screen now, please. I'm going to quickly show you how to get set up. All right, so what you can see here, the first thing you'd need to do is to create the device within the TTI console. So you first create an application, add the device to the application, and from there you'd be able to get hold of an application key, an application EUI, and a device EUI. The next thing you would do is go to the XDK Workbench and go to the app controller file here and enter those details into here, and that will configure the LoRaWAN module to be able to communicate with the join and communicate with the TTI network. So once you've done that, you should then start to see data streaming up into the LNS. So this is the device. It's sitting outside on my decking at the moment, and it's sending out messages every 10 seconds. So in a few seconds, there we go. There's the first uplink message that we've seen. So once you've verified that the device is actually communicating with the ThingStack, you can create one of the integrations that was demonstrated previously. There's my integration. I've already set it up. So this is now pushing messages from the XDK onto some topics. And here are those messages coming up in real time. We can see that the payload is not encoded. It's already in JSON. And there we can see barometric pressure, luminosity, humidity, and temperature. So from there, and this is detailed more in the instructions, but in there you would actually move on to cloning the GitHub repository where the samples are held and setting up your project on your local laptop or your Cloud9 development environment. So from here, this is an Amplify project. AWS Amplify really takes care of two parts of the application. Firstly, it allows you to define the backend, which is in this case AWS AppSync with a bunch of Lambda functions and other features. But it also allows you to define the front-end application as well. And in this case, it's a React.js application that is using some of the out-of-the-box GraphQL connectors to subscribe to that streaming data coming from AppSync. So I'm not going to go into the code in any more details here, but you can take this sample, modify it, and play with it yourself. So once that's deployed, and you can deploy both the backend through the continuous integration tools provided by AppSync, as well as start up the application locally, which will give you basically a React.js app running locally. So I'll just refresh the data quickly. And within about 10 seconds, we should see real-time data coming through AppSync, which is being updated from that Lambda function. And this React.js app subscription will update the details on the screen to show that live data. So there we go. That's live data updating. The graphs in the sample app start from the time that the page refreshes, and we'll build out as time goes on. So we'll come back to that in a second. The second thing I wanted to show you though was how to very quickly create a QuickSight dashboard for retrospective data that will contain data from the time that you actually deployed the back end. So it's persisted for a long time. So in addition to updating the GraphQL endpoint via a mutation, we're also using that Lambda function to push data to IoT analytics. And I won't go into analytics in any great detail, but it consists of channels, pipelines, and data stores to persist the streaming data coming from the LNS, and then data sets which are then out of the box available within Amazon QuickSight. So I'm going to set up a very quick analysis based on the data set that has been created automatically by that Amplify project. I'm just going to do create analysis, and in this case we are going to map time against luminosity. It's getting dark outside, so we should be able to see something. I'm just going to set that to average luminosity over a time period of 1 minute, and there we go. We can see a graph. I put it outside from a dark room to the sun shining outdoors, so you can see it leapt up in luminosity there for a moment. But if I limit the time period to the time it was outside, you can see the sun is setting here slowly. I just wanted to demonstrate that the other value you can get from tools like Amazon QuickSight, which is the ability to add a machine learning forecast to forecast a future period very easily and quickly without any machine learning knowledge. So if I hit apply there, we've got 90% confidence level and 10% confidence level in continued prediction streaming from this data. So if we finally take a jump back to the IoT dashboard, There we go. We can see luminosity has been updated and barometric pressures moving as well. So both this Bosch application plus some applications for other devices will be available at the published URL. You can download that, and it should really help to get you started with the Bosch XDK and with other devices. So over to you.
Cool, thank you, Chris. It's really exciting and really good to see the whole journey now. And I think all the information is quite a lot and could be quite overwhelming. But it's really good that you have the source code available for people to look at it and to play with it themselves. And that's also, by the way, for the slides. So I wanna conclude now with just the resources for you to get started. So one of the things that you need in a LoRaWAN network is a gateway. So you can buy this gateway, which is a indoor gateway, which has a Wi-Fi backhaul. It's AWS qualified, and it runs Amazon FreeRTOS, and it connects directly to the Things stack. And it can be remotely configured and updated easily. So that's for the gateway. And like I said, we are vendor agnostic. You can connect any LoRaWAN gateway and any LoRaWAN end device. So you just saw end devices from Tekelek and Bosch, but there are hundreds and hundreds of LoRaWAN devices out there that you can all use with this solution. Look at the notes on the video. You can find the links and also a few more links. But you also see it here in the slides. So we have the documentation to deploy the integration. We also wrote a blog post together on what the benefits are of using this integration. You can go to our seller profile on AWS Marketplace, so you can subscribe to our SaaS or AMI subscription. You can find more documentation in general, and finally there's the link to buy that $89 indoor LoRaWAN gateway from Amazon.com. So in summary, LoRaWAN, which is the de facto LPWAN standard, offers a wide range of devices, many different applications, and it's very much complementary to any existing IoT solution out there. So we have different deployment models for our network server in AWS, depending on your requirements. And we built a very easy integration with the Things stack and AWS IoT Core for telemetry, device management, security, and other metrics. We have a getting started with the sensors that Chris just presented. You can find that on GitHub to get started quickly. So that's the content. We know it's quite dense, but we now have time for questions. So if you have any, then we're happy to address them.
Thank you very much for that, Johan. So that concludes the webinar portion. So let's now jump over and take a look at some of the questions which came in. So let's begin with the first question here that came in. What is the average delay of 20 plus bytes of payload to be sent received? Johan, would you like to take that one?
Yeah, sure. So that's a great question. Thanks, Matthijs, for asking. Yeah, there are different aspects to this question. If you just look at the delay of how much time it takes from, for example, pushing a button on a LoRaWAN end device and receiving that uplink message in your AWS account via the integration as we presented, then it depends on a few things. So, for example, the gateway backhaul. So, does the gateway have an IP, like an Ethernet connection, or is it cellular or even satellite? The geographical factors, like is the gateway far away? Which AWS region are you using? And is that close to the gateway? Things like that. So it varies between, let's say, 50 milliseconds to a few hundred milliseconds normally. If you talk about the round trip time, so how much time is in between sending a message and receiving the response, so a downlink message on the LoRaWAN end device, then that is actually configurable. That's the LoRaWAN RX1 delay. And in the Think stack, we use 5 seconds by default. And the reason for that is that we consider that enough time to make round trips for the LNS, for the application layer, to do some computations and respond with a downlink message. So that's 5 seconds. If you need a shorter round trip times, then you can reduce that also via configuration.
Okay, great. Thank you, Johan. We have another question here. Can I modify the sample apps for working with other devices? Chris, do you want to take that one?
Yeah, thanks, Karthik. Yeah, absolutely. The sample apps are distributed under the MIT license, so you can freely modify those and share with other people, and then change the data mappings, etc., inside the apps to use them for other devices.
Great. There's another question here. Which devices will work with the TTI system? I'll take that. So the complete end-to-end solution is based on LoRaWAN standards. So you can connect any LoRaWAN compliant device. If you want to go find a list of devices, you can visit the LoRa Alliance website and click on Device Showcase, and you'll be able to browse through a number of different devices which are available on the market, which you can connect. So the next question we have here, do you use Cognito for user management? Back to you, Johan.
Yeah, that's a good question. So we don't use it by default, but Cognito is for those who don't know, it's an AWS service for user identity. Since Cognito supports a standard called OpenID Connect, you can actually configure the Think stack to use Cognito for user authentication. So yeah, the answer is yes, because we the Think stack supports and it has its own user and password login flows. But for enterprise use, you can also configure any OpenID Connect provider, including AWS Cognito.
Great. We have one more question here. Where can I download the sample AWS apps? Chris?
We're going to put the URL for the sample apps in the YouTube description once the YouTube video turns into a pre-recorded video after this live webinar. And it'll be a GitHub repository, so you can download it from there.
Great. And we have one final question regarding the LoRaWAN indoor gateway that was presented. Does it support AS923 frequency? Johan, you want to take that one?
Yeah, that is also supported.
Excellent. All right, well, this concludes our webinar. We'd like to thank you all for joining and wish you a great day.